Welcome. Today we're going to talk about solving two-step equations. Solving two-step equations is really not that difficult to do. It may seem like it is at first, but it really isn't. You can just follow some basic rules and you should be fine. And here they are. Number one, keep your writing clean and organized. I know that seems like such a ridiculous thing to say in a math class, like, well, who cares what my handwriting looks like? But math, the secret of this type of algebra is that more often than not, the mistakes you make don't really have much to do with your ability to do the math. It just has to do with your ability to remember what was happening or figure out where you are or not losing things like dropping a negative. Those sorts of things cause problems. So keep your stuff clean and organized, and you'll be better off. Also, with that, I should say, writing things down. The more steps you write out, the easier it is to figure out where you make a mistake. It also, in the early going of solving equations, is good practice because it helps your brain sort of have an entire experience. You can't have you can't really make a memory with one sense. It requires every memory that you have has at least a few senses involved. So the more writing you do, it builds thought. It builds thought in your brain and makes it all work together. So write some stuff out. Do yourself a favor. The second thing, use opposite operations. It's almost like we're going to reverse engineer the process of building an equation. So if I have, say, x plus 5 is equal to 3. Actually, let's make it x minus 5 is equal to 3 to make it even easier. So I know for a fact that 8 minus 5 is 3, so that's simple. But the process that we're going to use is sort of working it backwards, not thinking, okay, what minus 5? I need to do something with the 5. So I'll identify the variable, and I'll just eliminate everything that's on the same side of the line with it and then move it around. So to get rid of minus 5, I want to do plus 5 because it'll help me tell the story of where it all started. So x is equal to 8. So in this case, 8 minus 5 is 3, but to find that out, we needed to use the opposite of subtraction, which is, of course, addition. And the last one is self-talk. Now, you don't have to talk yourself like, you can do this, you can do this. If you need to do that, you can do it. But the real value is just sort of saying to yourself, what does the equation say? For instance, in this question, I needed to say minus 5, because when I did that, it triggered in my head that, okay, to get rid of it, I need to use addition. Just because I'll say, oh, it's minus 5, well, okay, plus 5. You'll go that very quickly. After a little while, you don't need to do it anymore. But it's okay to say what's going on to yourself so you know where to go next. It also sort of slows things down, which might be a big deal. Okay, let's do some sample problems, shall we? 6v plus 4 equals 118. So what I want to do here, the first thing I always do is draw a line down the equal sign, just because it helps me identify where the variable is and what I need to do with it. In this case, all I'm going to do is eliminate things that are keeping the variable from being by itself. Here's my variable. I'll just highlight it. So specifically what I'm looking for now is what number or term or whatever is furthest away from the variable but on the same side of the line. Because this 118 is not really having any effect on the v. It doesn't do anything to it right now. But the 4 and the 6 do. So I'm going to eliminate the thing furthest away. That way it simplifies faster. This 4 is being separated by an operator, so it's plus 4. I need to eliminate it. To get rid of plus 4, I need to subtract. Obviously. These cancel out because you'd end up putting plus 0 here, which in math and algebra especially, you don't really do that. You want to keep things clean. So we'll get rid of them. I'll bring down the 6v because I didn't use it. 118 minus 4 gives me 114. The reason I have minus 4 here, if you do something to one side of an equation, you have to do it to the other. Otherwise, you're making them not equal anymore, and then the whole equal sign thing would be a lie. That's not a way you want to live. So finally, the v is just with the 6. If they're touching, this means multiply, so this is 6 times v. In order to get rid of times, I need to divide, because that's the opposite operation. So v is equal to 19. As a little test at the end, you can always substitute the value back in. So 6 times 19 plus 4 should equal 118. And if I do 6 times 19 plus 4, I'll get 118. 118. It's the same. So I've tested it and it's worked. Do you have to check it every time? That's not up to me. It's up to you and whatever instructor that you have that wants you to do it. If they want you to do it, just do it. Make them happy. In this set of after I draw the line, you'll notice that the variable is on the right side. Some people have a real issue with that. Like, it could never be on the right side. But the thing about the equal sign is that it doesn't care what side things are on. It just cares that eventually, when you have a finite answer, a final answer, I should say, that the two sides are the same value. It doesn't matter what side the variable's on. So get it out of your head that it always needs to be on the left. That's a bad situation. Here's the variable. Furthest thing away is not the 3. It's right next to it. So I'm going to get rid of minus 9. To do that, of course, plus. So addition. If I do it to one side, I need to do it to the other. Those will just go away, cancel each other out. Negative 12 plus 9 is negative 3. One of the other things I've seen people do is they don't put a sign here, they just put 9. It's a really dangerous habit to do that because all of a sudden you start multiplying or dividing or whatever because you forget what's going on. So just do yourself a favor and put the plus 9 there, at least in the beginning while you're building your skills. Finally, I'm at the last step. Times 3 is the relationship. I need to get rid of it through division. N is equal to negative 1. To test it, 3 times negative 1 minus 9. Here we go. Check. So I know that's the right answer. For this one, it starts to look a little bit different, but not significantly different. All the same rules apply. Now in this one, you'll notice that the variable term is in a fraction. It's the numerator. That represents division. A fraction is division. 1 over 4 is the same as 1 divided by 4, which is 1/4. It all means the same thing. So this is just a division. But we don't need to worry about that in this first part of it because it's not, this 4 is not the furthest thing away. Anytime you have this kind of relationship, if there's a number outside of the entire fraction, you need to eliminate it first. So really, this says plus negative 4. Now, you may say in your head minus negative 4. To me, that's like a lot of signs that I don't want to deal with. So anytime I have whatever sign here, I just apply it to the fraction here. So I'd say this is plus m or positive m or whatever. Whereas I'd treat this one, because the relationship is addition between the fraction and the constant, I would say that, okay, it's an add-subtract relationship. That's what I'd say in my head. So I would treat this as minus 4. To get rid of minus 4, I would just say plus 4. And that's a legit method just because if I had this, which is what this would be if I flip the order around, and in an addition case, it's fine. They're commutative. So I would get this anyway. So you do plus 4 to get rid of it, just like I did. So it doesn't, that's fine. Just change your self-talk around a little bit. No big deal. 1. Finally, I need to get rid of divide by 4. So to do that, I'm going to multiply by 4. M is equal to 4. Can I test it? Of course. I mean, obviously. Put 4 here. Negative 3 equals negative 4 plus 1. Perfect. One more and we're done. So in this case, a big shift in how it looks. It's not a huge shift. It's a little shift, but it's still a shift. In this case, the negative 7 plus b almost acts as a term that you need to deal with separate from the divide by 10. Now you'll notice in this problem that we just did, only the variable is being divided by 4. Whereas in this, the entire numerator is negative 7 plus b. So the furthest thing away from the variable, which is here, because the entire term is in the numerator, is actually the 10. So we're going to get rid of divide by 10. To do that, we need to multiply, obviously. Well, why does that work? Okay, so if I have 3 over 10, and I multiply the whole thing by 10, it goes in 10 over 1 is the same as 10. So it'll actually give you, this 30 over 10. That just makes it look confusing. I'll fix that really fast. it equals 3. But if you look here, when we're at this point, these just cancel each other out and you end up with a 3 anyway. So that's why the divide by the entire thing being divided by 10 can be rectified by simply multiplying the whole thing by 10. The key here is to do 10 times 1, obviously. That's part of the key. But here, times 10, times 10. Those sort of cancel. Bring the entire term down. Negative 7 plus b. Now in this case, I only have one thing left, and we talked before about how this is plus negative 7, but you could also just say minus 7 in your head. To get rid of minus 7, I'll add. $17. I definitely want to check that one because it's a bit of an odd one. So, negative 7 plus 17 over 10, positive 10 over 10, and it works. So that's it. Solving two-step equations really isn't super difficult. Just keep things nice and organized. Give yourself a little self-talk and remember to use opposite operations and everything should go fine and dandy.